All right, moving on to chapter 1, section 6. There's only 7 sections in chapter 1, so we're getting pretty close to being done with chapter 1. So, 1.6 is solving absolute value equations. So, an equation that has an absolute value in it. Can anyone tell me anything that we know about absolute values? Yes.
If it's like a negative, then it goes straight to positive.
If it's a negative, it makes it positive.
It goes to the natural state of it.
Say it again.
It goes like to the natural state of what it was.
Natural state of it.
It's how far away a number is from 0.
Yeah, very good. It's a distance from 0, right? So when you see an absolute value, it's asking, hey, how far is this number away from 0? Okay? When we're dealing with equations, though, we'll have variables inside the absolute value. So we're not going to know what number it's exactly talking about. Okay? But I'll show you how to solve our absolute value equations. What values of x would make this equation true? 3. Is that the only number?
3 times 1.
What?
Negative 3.
-3. Does everyone understand that? If I plug 3 in for x, what's the absolute value of 3? 3. Is that a true statement? Yep. If I plug in -3, what's the absolute value of -3? The distance of -3 from 0? 3. Is that a true statement?
Yes.
How many solutions do I have here? 2. Up to this point, we've only had one solution, no solution, or infinitely many solutions, correct? So, we can get 2 solutions with our absolute value equations. In fact, most of the time we will. Okay? Because we have to account for that positive and that negative value. Does that make sense? So most of the time when we're solving our absolute value equations, we will get 2 answers. Questions on that? Okay, the next slide is going to be a lot of words. I'll show you the part that I want you to write down. Okay? Don't write all that down. I mainly want you to just write this stuff down here. Okay? The rest of it I'm just going to talk through. An absolute value equation is an equation that contains an absolute value expression. You can solve these types of equations by solving 2 related linear equations. One equation that accounts for the positive value, one equation that accounts for the negative value. So some properties of our absolute values. Let a and b be real numbers, then the following properties are true. The absolute value of a will always be greater than or equal to 0 because it's always going to spit out a positive number, correct? It'll always spit out 0 or a positive number, so it'll always be greater than or equal to 0. The absolute value of negative a is going to always be the same as the absolute value of a. Because once again, it's always going to spit out that positive value due to it being the distance from 0. If I have the absolute value of a times b, that's going to be the same as if I take the absolute value of a, take the absolute value of b, and then multiply them. So the absolute value of a times b is the same as the absolute value of a times the absolute value of b. And then same thing with division. Absolute value of a divided by b is the same thing as absolute value of a divided by the absolute value of b, when b does not equal 0. So those are just some properties that are true of our absolute values. The bottom paragraph that I had you write down, this is how we're going to solve our absolute value equations. To solve the absolute value of ax plus b equals c, this is an important part. When c is greater than or equal to 0. What does that mean? C is greater than or equal to 0. If c is greater than or equal to 0, what does that mean? Not quite. 0 or higher, so what type of numbers? Positive. So, in order for us to set up our two equations, I need my C value here to be 0 or any positive number. If it's a negative number, I can't set up my two equations, and I'll explain that here in a little bit. So, to solve absolute value of ax plus b equals c, when c is greater than or equal to 0, solve the related linear equations. Ax plus b equals c, or ax plus b equals negative c. What do we notice about this first equation and my original? What do we notice about these two things? This first equation and my original equation. Well, I'm talking about from this one to this one. Say it again. Yeah. So when I'm setting up my two equations, my first equation is going to be the exact same as my original, just without the bars. Does that make sense? And then what do we notice about the second equation? We already pointed it out.
The second one's negative.
The C value on the second one's negative, right? That's me accounting for the positive and the negative value, like we talked about earlier. Does that make sense? So when we set up our two equations, the first one will be exactly the same as our original without the bars. Second one is the exact same, we just make our C value negative. Okay? When C is less than 0, what numbers are less than 0? Negative numbers. So when my C value is negative, the absolute value equation, absolute value of ax plus b equals c, has no solution because absolute value always indicates a number that is not negative. In other words, it's always positive, right? If I plug something into an absolute value, it's always going to become positive, correct? So if I plug something, or if I get an equation saying my absolute value equals a negative number, will that ever happen? No. No number would ever make that true, so that would be no solution. Okay? Can I move on to some examples to hopefully make things clear? Okay. Solve each equation, graph the solution if possible. And we're just going to graph them on a number line. So don't worry about that. We will graph them, but it's not hard. Letter A, absolute value of x minus 4 equals 6. Absolute value of x minus 4 equals 6. Absolute value of x minus 4 equals 6. So, in order to solve this, like it said, we need to set up two equations. What do we say about the first equation? It's going to be the, bless you, same thing without the bars, right? So looking at the equation that I have, what's my first equation going to look like? X minus 4 equals 6. The same exact thing without the bars. Does that make sense? I'm going to go ahead and set up my second equation. What's our second equation going to look like? Same thing, but now I'm making my C value negative. So x minus 4 equals negative 6. Does everyone see that? To solve an absolute value equation, we have to set up two equations to account for our positive value and our negative value. Okay? First equation is the exact same without the bars. Second equation is the exact same, making the C value negative. From here, I'm just solving those two equations to get my two solutions. So on both of these, what's my one step to get x by itself? Add 4 to both sides. Everyone okay with that? So first equation, 6 plus 4 gives me 10. There's one of my solutions. Second one, negative 6 plus 4 gives me negative 2. I've just found my two solutions for my absolute value equation. Any questions on how we got that? Can I erase my work to go ahead and check my solution? Okay, so if I plug in 10 to my original problem, 10 minus 4 gives me what? 6. Absolute value of 6 gives me 6. Does 6 equal 6? Yeah, it's a true statement. 10 checks out. I know 10 is the solution. Plugging negative 2 in. Negative 2 minus 4 gives me negative 6. Absolute value of negative 6 gives me 6. Does 6 equal 6? So I know negative 2 is a solution as well. Any questions on that? What's the last thing it wants us to do? Graph them. So once again, I'm going to erase this stuff up here. Draw my graph. I do want you to graph it if it asks you to graph it. How do I graph it on a number line? It's pretty easy. I just put the points at my solutions. So I'm putting a point at 10, putting a point at negative 2. Any questions on that? And I'm done with the problem. Questions there? How do I feel after one example? Letter B. Absolute value of 3x plus 1 equals negative 5. Can I erase letter A to give me some more room? Okay, any ideas here on letter B? Absolute value of 3x plus 1 equals negative 5. Any ideas? On what I need to do first? Any ideas what to do here?
3x plus 1.
What else?
3x plus 1 equals 5.
Everyone agree with that? I disagree. Think about our little paragraph down here in our C value. In order to set up our two equations, what has to be true of C? Huh? Has to be greater than or equal to 0. So 0 or positive. Is my C value 0 or positive? No, it's negative 5, right? It's less than 0. What does it tell me I need to do if my C value is less than 0? No solution. So, I can't set up two equations here. I just write no solution and I'm done. Does that make sense? Because any number I plug in for x here, it's always going to spit out a number that's 0 or greater than 0. So positive, right? Will 0 or any positive number ever equal negative 5? No. So there's no number that will ever make this equation true. So I don't have to do any work here. I just see that my absolute value is set equal to a negative. Can't do it, no solution. Those are nice problems right there. Any questions on that? And understand why it's no solution. We good? Can I move on? Solve absolute value of 3x plus 9 minus 10 equals negative 4. Any ideas here? Absolute value of 3x plus 9 minus 10 equals negative 4. Any ideas?
3x plus 9 minus 10 equals 4.
Say it again.
3x plus 9 minus 10 equals 4. You said positive 4.
Not quite. No solution? How many of us think it's no solution? I can see why you think it's no solution, but that is not the case. This one's kind of a trick one. Throwing a curveball at you. Here, I've got 10 being subtracted from my absolute value, correct? When I'm setting up my two equations, does this equation have anything being added to the absolute value outside, subtracted from it outside, multiplied by it, or divided by it outside? No. So before I set up my two equations or determine if it's no solution or not, I need to get the absolute value completely by itself. Does that make sense? In this case, the absolute value is not completely by itself because 10 is being subtracted from it on the same side of the equation. Does that make sense? Got to get the absolute value by itself. How would I do that in this case? Yep.
You do plus 10.
Yep. I'm going to use my inverse operations just like we've been doing. Add 10 to both sides. Negative 4 plus 10 gives me 6. Questions on what I've done so far? Is my absolute value now by itself? Nothing added to it from the outside, subtracted from it, multiplied by it, divided by it on the outside? It's completely by itself, isn't it? Now I can start looking at it, looking at my C value. What is my C value in this case now? 6. Is that greater than or equal to 0 or less than 0? Greater than or equal to 0. If it's greater than or equal to 0, I can now set up those two equations. Does that make sense? So what's my first equation going to look like here? 3x plus 9 equals 6. The exact same as my original, just without the absolute value bars. My second equation, what's that going to look like? 3x plus 9 equals negative 6. The exact same, making my C value negative though. Once I set up the two equations, I can now start solving them both for x. So what's my first step on both of them to get x by itself? Subtract 9 from both sides. On the left, 3x equals what's 6 minus 9? Negative 3. On the right, 3x equals what's negative 6 minus 9? Negative 15. Now, what's my last step on both of them to get x by itself? Divide by 3. Negative 3 divided by 3 gives me negative 1. Negative 15 divided by 3 gives me negative 5. So my two solutions are negative 1 and negative 5. Does everyone see how we approach that? So always, always, always make sure your absolute value is completely by itself on one side of the equation. Nothing being added to it on the outside, subtracted from it on the outside, multiplied by it on the outside, or divided by it on the outside. Once you do that, check your C value. If it's greater than or equal to 0, set up your two equations and solve them. If your C value is less than 0, your answer is no solution. Okay? Any questions on that? If I plug this in, negative 1, 3 times negative 1 gives me, I'll just go ahead and do it, negative 3. Negative 3 plus 9 gives me 6. Absolute value of 6 is 6. 6 minus 10 would give me negative 4, so that one checks out. Plug negative 5 in. I get negative 15 plus 9, which would be negative 6 as well. Absolute value of negative 6 is 6. 6 minus 10 gives me negative 4. They both check out. Everyone good with that? Can I move on? All right. With our equations yesterday and the day before, we had what we called special solutions, right? There was no solution or infinitely many solutions. Here, with our absolute value equations, when you solve an absolute value equation, it is possible for a solution to be what we call extraneous. An extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. So, it looks like it's a solution, but I plug it in and it gives me a false statement in my equation, which means it's not a solution, right? So that means I cannot accept it as a solution. So in those cases, I would just have one solution for my absolute value equations. Okay? So on some of these, you will have to check your work, check your solution, and I do want to see that work on your paper. I want to see you plug it in and see if it works or not. Can I move on to my last page of examples? It's in the book. So whenever if you take a picture of the page, you can take a picture of this as well. But for time's sake, I'm going to go ahead and move on. So this is my last example here. Solve 2x plus 12 equals 4x. Check your solutions. We do need to go ahead and check our solutions here. First off, is my absolute value completely by itself? Yes, there's nothing added to it, subtracted from it, multiplied by it, or divided by it. Is my C value greater than or equal to 0 or less than 0? We technically don't know here because we have x as our C value as well, but we're going to assume it's greater than or equal to 0 and set up our two equations. Okay? So what would my first equation look like? 2x plus 12 equals 4x, exactly the same without the bars. My second equation, I make the 4x negative. Very good. Any questions how I set these two up? Okay, looking at the left equation, what would be my first step here? Not quite. Think about the past 2 days with our equations with variables on both sides. I can't combine them yet because they're not on the same side of the equation. Subtract 2x. I want to get my variables to the same side of the equation. So I'll subtract 2x here and here. 4x minus 2x gives me 2x. From there, how would I get x by itself? Divide by 2 on both sides. So for this one, x equals what? 6. Questions how we got that? The right equation, 2x plus 12 equals negative 4x. What would be my first step? Subtract 2x from both sides. Getting those variables to the same side. Negative 4x minus 2x gives me negative 6x. And how would I get x by itself? Divide both sides by negative 6. Here, x equals what? Negative 2. So I'm saying x equals 6 and x equals negative 2 are my two solutions, correct? But we need to go ahead and check our solutions to see if we have any extraneous solutions. So can I erase all my work down below the problem so I give myself some more room? We got all the work written down? So when I plug in, I've got to plug into both variables. Okay, we'll finish this up and then I'll get you guys rolling. So plugging in 6. 2 times 6 gives me 12. 4 times 6 gives me 24. 12 plus 12 gives me 24. Absolute value of 24 is 24. So is 6 a solution or not? Yes, it is. 6 gives me a true statement, so 6 checks out. 6 is a solution. Plugging in -2. Sorry, I'm moving fast. I'm just trying to get this all in for you. 2 times -2 is -4. 4 times -2 is -8. -4 plus 12 be 8. Absolute value of 8 is 8. Does 8 equal -8? No. So is -2 a solution? -2 is not a solution, so I have to reject it. I just have one solution here of 6. Does that make sense? Any questions on that? Okay, you guys ready for your assignment? Can I move on to the assignment? Okay, we're still writing? Okay, I'll give you time to write. Just kidding, we don't have an assignment. We'll get it tomorrow. Okay? Any questions about the notes before I end the recording?